during the clock pulse is present and inputs are 1, 1. So that is the main drawback of JK flip-flop. To overcome that drawback, we are using, or that condition is called race around condition. If inputs are 1, 1, that is the J is equal to 1 and K is equal to 1, the triggering is present. During the triggering, the output will be continuously changing from 0 to 1, 1 to 0, 0 to 1, 1 to 0. Continuously that will change. That condition is called race around condition. Okay. So to overcome this race around condition in the JK flip-flop, we are using master slave JK flip-flop. Master slave. Ante first flip-flop we are calling as a master. The second flip-flop we are calling as slave. The two flip-flops we are connecting cascading. What is the, do you know the cascading connection? Cascading. Series connection. Series. What is the meaning of series connection? The two flip-flops are there. The two flip-flops you can connect to the connector in series. Ante the first flip-flop outputs we are connecting to the second flip-flop inputs. Okay. So that is called cascading connection. So if you are connecting the two flip-flops JK1 and JK2 flip-flops, the race around condition can be eliminated. Okay, that is the JK flip-flop. And the T flip-flop can be the two more flip-flops, the T and D flip-flop. The T flip-flop can be derived from the JK flip-flop. T flip-flop can be derived from JK flip-flop. And D flip-flop. T stands for T flip-flop ante. T flip-flop. T stands for చెప్పారు ఎవరో కరెక్ట్ చెప్పారు. Toggle. T stands for toggle. What is meaning of toggle? Changing the output 1 to 0 or 0 to 1. 0 unte 1 అవుతుంది, 1 unte 0. So that is called toggle. Next, the D flip-flop. The D stands for data. This D flip-flop can be derived from SR flip-flop. Okay. So now this is the all flip-flops are 1-bit storage devices. Using this flip-flop, we are designing the registers. If you are using the 4 flip-flops, then that is called bit register. If you are using the 8 flip-flops, then that is called 8-bit register. The register size is 8-bit register. Now coming to the, I given the one question, C is equal to A plus B. C is equal to A plus B. Before coming to that, you can take the one register. 1, 2, 3, 4, 5, 6, 7. How many total? 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. This is the flip-flop 1, flip-flop 2, 3, 4, up to 8 flip-flops. Now, this is called 8-bit register. 0, 1, 2, 3, 4, 5, 6, 7. 7. 0, 1, 2, 3, 1, 2, 3, 4, 5, 6. 0 to, that is the 8-bit register. So now, using the 8-bit register, what is the minimum data we can accommodate and what is the maximum data we can accommodate in that 8-bit register? Minimum data, minimum number. The minimum data is 0, 0, 0, 0, 0, 0, 0, 0. What is the maximum data? All ones. So that means this value is the 0, 0, H, and the maximum value is 1, 1, 1, 1, 1, 1, 1. What is the value? 1, 2, 3, 4. 4-bit, 4-bit. FFH. This FFH value is the hexadecimal value. For this, the What is the value? So if you are having the 8-bit register, we can accommodate 0 to 255 decimal value. 0 to 255, any number. 1, 2, or 100 or 121 or any value in between, we can accommodate. Okay. So now use the expression C is equal to A plus B. C is the output variable and A is the input and B is the input. Okay. So before executing that expression, the A value can be assigned to one of the register in the processor. Are you studied the different registers in CO? అదే DLCO. I think register concepts you don't have. Okay, registers. If you want to design the simple computer, some mandatory registers are required. That is, one is the main important register, accumulator. Accumulator. That is one of the important register in the any simple processor. Okay. The next one, some temporary registers and data register and program counter. Are you heard about the program counter? Program counter. Program counter. Hmm? Okay. Address register. Right. Some conditional flags. Okay. See, you can take the expression C is equal to A plus B. That is a human writing program application that we are storing or saved in the processor memory. There is a computer memory. So after writing the program, you are saving the program in the computer memory. Now, after saving Control S, then you are executing the program. While executing that program, the processor reading first where that instruction is stored in the computer memory. Phone undi. Phone lo data undi. Some images. Phone open చేసినాక ఏం చేస్తారు? ఏ రోజు ఫోటో క్యాప్చర్ చేసామో ఆ డేట్ లొకేషన్కి వెళ్ళి వీఆర్ సి. సిమిలర్లీ యు ఆర్ రైటింగ్ ద ప్రోగ్రామ్, ఫస్ట్ వీఆర్ సేవింగ్, సో దెన్ వీఆర్ ఎగ్జిక్యూటింగ్. Before without saving we can't execute or we can't run the any program, any programming language. You can take the C, DS, CPP, Java, Python, whatever it is, any high level languages. After running the program we are saving with a suitable file extension. After that we are executing the program. మీరు సేవ్ చేయట్లేదంటే ఆ కంపైలర్లో ఒక అడ్వాంటేజ్ ఉంటుంది, ఆటో సేవ్ చేసుకునే ఫెసిలిటీ. అది మీకు తెలియకపోవచ్చు. ఆటో ఫెసిలిటీ ఉంటే సేవ్ చేస్తున్నది అర్థం కాదు. పైథాన్ ఉంది, పైథాన్ ఇస్ ఆటో సేవ్. ఒకసారి సేవ్ చేశారంటే దెన్ ఆటోమేటిక్లీ దట్ విల్ సేవ్. ఓకే, సో నౌ ఆఫ్టర్ సేవింగ్ దట్ ప్రోగ్రామ్ ఇన్ ద కంప్యూటర్ మెమొరీ, దెన్ వీఆర్ ఎగ్జిక్యూటింగ్. సో at the time of executing, the processor reading that instruction location in the memory, that instruction is where it is present. Okay, for that instruction the processor is generating one machine code, that is called the operational code, op code. మనం రాసే లాంగ్వేజ్ ద కంప్యూటర్ కెనాట్ అండర్స్టాండ్. అది ఆ లాంగ్వేజ్లో కన్వర్ట్ చేసుకుని మిషన్ లాంగ్వేజ్లో కన్వర్ట్ చేసుకుంటుంది. Okay, so now that code can be read by the processor. Now the processor is executing. So the processor is stating A is the first variable, B is the second variable. So the which value is assigned to the A and which value is assigned to the B. Then after retrieving the data from that memory, then addition operation can be performed. For that addition also we are designing the one circuit, logic circuit. I think you studied that logic circuit components in the third unit, computer arithmetic operations. Addition program, hardware structure and algorithm. The multiplication, hardware structure and algorithm. Okay, so you already studied this in the computer arithmetic. Then after designing this computer arithmetic algorithms, then how we are executing. So what are the execution steps are present, we'll come to know later. Now coming to this, the basic structure of computers. This is the interesting and easy topic in your CA, in your DL and CO. That is the basic structure of computers. The syllabus is what are the different types of computers are present and what are the basic functional units and operational units and what are the bus structure. Bus ante endi? What is bus? Set of wires. Correct. Set of wires. Next, software, performance and multi-processors and multi-computers. See, the multi-processor and multi-computer means in this monitor or in this processor, I am using, what is this? Screen, output screen. And the same way, I open the writing pad, then Zoom live. How many tasks are running here? 3 tasks. One is Zoom live and writing, then PDF. 3 tasks and one more, this one also, voice. So the 4 multiple tasks are performing parallelly. This operation is called the multiprocessing units. The multiprocessing units, that is also called multi-computers. Next one, the computer generations. That means computer generations means the which computer invented first, then what is advanced and what is the present processor. Okay, next, the von Neumann architecture. You are saving, if you are in the one program, C is equal to A plus B కి ఒక కోడ్ ఉంటుంది, ఒక మెమరీ అసైన్ అవుతుంది కదా. సో దట్ ఈస్ కాల్డ్ ఇన్స్ట్రక్షన్. దట్ ఇన్స్ట్రక్షన్ కెన్ బి స్టోర్డ్ ఇన్ ద మెమరీ. అదే సేమ్ ఇన్స్ట్రక్షన్స్ లో ఏ ఉంది, బి ఉంది, సి ఉంది. ఏంటి అవి? వేరియబుల్స్. సి is the output variable, A is the input and B is the input. For that input we are assigning some values, that is called the data. So if you are in the one program, the 2 memories are required. One is the code memory or instruction memory and other one is a data memory. what are the data we are using to perform. That is C is equal to 2 plus 3. 2 is the data and 3 is the data. The 2 and 3 can be stored in data memory, and instruction, the entire instruction that is the equivalent to machine code can be stored in the program memory. So how that program memory and code data memory are using the same memory device or different devices, that is comes under the Van Neumann architecture. Okay. So now we'll open the enter into the basic structure of computers. Okay. The basic structure of computers. First one is basic computers. Computer types. Okay, what are the computers? You know, what are the, as per your knowledge, tell me the basic computers. What are the different computers you seen in the real life? Hmm? Different computers. Laptop and desktop both are same. Or different computers. The purpose is same. Applications also same. The laptop can be easily carrying. Desktop we can't. Like that. So the two different computers. There is a desktop computer and a laptop. Any other? Hmm? Lab. Tab. Okay, good. Tab also. Tab also one of the computer. Nowadays, mobile phone also. It is also one of the computer. What are the operations you are performing using the laptop or computer? The same we are doing in our mobile phone. But it is limited. We can't run the Java language in our mobile phone because that is not compatible for the Java programming. Okay, but remaining other purposes, we are using the PPT, Word, and using internet. All are same. Okay. Other computers. Okay, thing. Next, basic computers and basic terminology. What are the basic terminology of the computers? Terminology. అవి యూనిట్స్ అవుతాయి టర్మినాలజీ. Okay, you can see computer. The computer can use data and that is performing the tasks and giving the output. Okay, you can see a device that accepts the input and process the data and that will generate the output. Okay, so that is called computer. And hardware. Hardware you are having includes the electronics and including the electronic and mechanical devices. Hardware is including electronic and mechanical device that process the data and refers to the computer as well as the peripheral devices. The peripheral means input and output devices. Computer and hardware. Hardware అంటే ఏంటి? Electronic chips and mouse, keypad. Keypad లో కూడా IC circuit ఉంటుంది, electronic circuits. Okay, that is the hardware. And coming to the memory. We said the program is having the two memories. One is the code memory and data memory. Sorry, code memory and data. Okay, so where we are placing that data and where we are saving in our program in the computer. So that is called the memory. Internal storage is called computer memory. In our mobile phones, you are using the 4 GB RAM and 64 GB memory. That 4 GB RAM and 64 GB is a ROM, read-only memory. So that is called the internal memory. Coming to the desktop computers, we are using 500 hard disk, 500 GB hard disk, and 8 GB or 16 GB RAM. That is called internal memory. Next, software. If you want to use that laptop or desktop computer, we need to install the software. The first one is operating system. You can use Unix or Linux or Windows, any operating system. After installing that operating systems, then application softwares. Application software. What are the application softwares? Apps. What are the apps? Application softwares. MS Office. What is the applications of MS Office? We can write the Word, we can type the text in the Word, and we can prepare the PPT. Next, we can use the Excel. The Excel is the ocean. The many options are present in the Excel. Right? So this is a application softwares and C language, Java, Python, .NET, and all other are the application softwares. Next, the next one is network. Network, what is the purpose of network in the computers? Are you sharing the data in the labs without using internet? Is it possible or not? No. Without using internet. All the computers are connected one computer to another computer. Connected internally. ఒక వైర్ తీసుకొని ఒక కంప్యూటర్ నుంచి ఇంకొక ఇంటర్నల్ వైర్ ఉంది. So can we share the data from the one computer to other computer without internet? Is possible. I think you are not used, but that is called the LAN. LAN ante malli internet e kaadu. So if you are connected the one in your laboratory 60 systems are present, the all 60 are connected internally one to one. Then we can share the data from one computer to other computer. So for the purpose or nowadays internet, that is called network. Okay, network. Next, peripheral devices. What are the peripheral devices we are using? Input, output, memory, storage and memory. So we are using these peripheral devices. So there is a basic terminology for the computers. One is the computer definition, then hardware, then memory, then peripherals and network. Okay. Next, computer performance and processing. Boot process. What is boot process? Boot process. Switching on the device. ఒకసారి ఆన్ చేసిన తర్వాతనే we can run the any application. We can type the MS Word or we can prepare the PPT or we can use the Excel. So before using that, we need to switch on. The switching on the device is called the boot process. Okay. The next one, data. The data can be represents the objects and values, numeric values or anything. Okay. Next, the information can be processed and stored, can be transmitted. The data can be processed and stored, that can be transmitting. The transmitting means the sharing the data from the one computer to the other computers. And next, input device and output device and binary data. Binary means the computer is using the binary only, but we are the computer is displaying the decimal numbers because of the OS and because of the application softwares. But the all internal operations, executing the data and processing the data, all can be done in the form of binary only. In data transmission also. But we are designing the Office, that is the MS Office, not MS, Microsoft Windows operating systems. Because of that, we are getting the data in the decimal data. That is a human-friendly data. The human-friendly data is the decimal only, not the binary. The binary data is the computer language, computer number, computer data. Okay. So now coming to the different types of computers. Okay. Types of computers. What is the first one? Personal computer. What is meant by personal? Personal use. Personal use, no one is nowadays no one is using the desktop computers personally. Only the laptops. The laptops are replaced, personal computers are replaced by the laptops. Okay, but the first computer is a personal computer. The personal computer is having separate monitor, separate input device, separate output. Output is the monitor only, and central processing unit CPU, and keyboard also separate, and mouse also separate. Okay, and power supply board also separate. All these we are assembling, and we are placing that computer on the table permanently. So it is called personal computer. Then the personal computer is not movable. Move cheyalante table మొత్తం move cheyali. Okay, so that is a personal computer. The next one, desktop. Desktop computer. The personal and desktop both are same. Okay, personal computers and desktop computers. And this desktop also on fixing on the table. Okay, so the second category is the desktop computer. The next one, laptops. In the desktop computers and personal computers, the monitor is placing separately, and the CPU, the central processing unit cabinet, also placing separately, and both are connected with data bus. Both are connected with the data bus. That data bus we are calling as RS-232. చూసారా RS-232 కేబుల్? మీకు ఐటీ వర్క్ షాప్ ఉందా? Are you connected the different components in the IT workshop? ఏం చేశారు ఐటీ వర్క్ షాప్? ఏముందమ్మా? Okay, so we are connecting the central processing unit cabinet and monitor. That wire is called the RS-232. RS stands for recommended standard. 232 is the number. RS-232. So we are connecting this monitor and the CPU cabinet with RS-232 cables. That is the personal computer and desktop computers. But this and one more device here, the speaker, the sound system. So if you are in the personal computer or the desktop computers, this all devices, the input, output, memory, all are separate devices, separate units that we are with the suitable wires. Okay, so that is the desktop and personal computer. And coming to the laptops, all this sound system, input keyboard, and mouse. Mouse is the touchpad in the laptop. Mouse and monitor and memory, central processing, it all are fixed in the one unit. That is called laptop. That is the laptop. The laptop is a portable computer that can be moved anywhere. Okay, so now after the laptop, what will be the next version of computer? Personal computer. That comes to the desktop computer. Personal ante there is a limited memory. Olden days lo personal data chesukodaniki they are purchasing the computers. After that, the desktop computer can be used by the anyone because of the more memory. After that, laptops. Laptop, desktop, and personal all comes under personal only, but you can use purpose are different. Okay. Now, what is the after this laptop? What will be the next computer version? After the laptop, I think daily you are seeing in your college the next type, not mobile. Hmm? Next, computer. That is also, these all are computers only. Based on the compact size and moving of that computers, different classification. The next classification also comes under that. Server. Winner? Can we use this your desktop or laptop as a server? What is meant by server? What is the use of the server? Using the servers, I think you are using in your laboratory. Why? Yes, correct. It can provide the information to the other computers. For example, one programming language is there. If you want to install that application language in the, if you are having the 60 systems, okay, so and that is a costly one application program, costly, and we need to provide for the 60 members in the lab. Okay, so that is a very cost. ఒక సిస్టమ్ కి 1 lakh ఉందంటే 60 సిస్టమ్స్ ఉంటే హౌ మచ్ కాస్ట్? 60 lakhs. So to replace that 60 lakhs, example, not the exact amount, just I am saying the taking the example. So for that, you can install the software, that application software in the one system, and that system is connected to the remaining all the computers in the laboratory. So that software can be provided to the all the systems. So we are purchase the only one package. That package is applying to the all the 60 systems. That is called the server. The server computer all are same, but the specifications are different. The process that is server specifications and the desktop and laptop specifications are different. So that's why next category is the server. Next one is server. Purpose is to serve the other computers. The server is used to serve the other computer. The same application language can be provided to the all the remaining 60 systems in the laboratory. So we are reducing the cost, software cost. Instead of spending the 60 lakhs, simply we are spending only 1 lakh by use of server computer. Okay, so this is serving for the other computers, and all other computer 60 systems are connected in LAN. What is the stands of LAN? Local area network. The LAN stands for local area network. Next one, workstation. Workstation, it is designed for the powerful tasks. అంటే అప్లికేషన్ లాంగ్వేజ్ ప్రోగ్రామ్ పెద్ద ఉంది అనుకోండి, సో we can't run that program in our laptop or desktop, so that can be used in the workstation. So this is the powerful desktop computer designed for specialized tasks, can tackle the tasks that require lot of processing speed. For example, in the laboratory, you are using the P4 computer. Okay, a P4 computer low, if you want run the, what is the latest programming language? You belongs to second year, right? What are the subjects you are studying? So that ML suitable software you can't run in the P4 processor, right? So that required the high-end processor is required for the machine learning programs. So the same. What is a workstation? So this can be designed for the specialized tasks. మనం ఇవన్నీ కాన్సెప్ట్స్ ఎప్పుడు చదువుతున్నాం? Not now. These are olden days computers. ఈ వర్క్ స్టేషన్ సర్వర్ అన్ని పర్పస్ లో వీ కెన్ యూజ్ అవర్ లేటెస్ట్ కంప్యూటర్స్. డెస్క్టాప్ వాడచ్చు, పర్సనల్ వాడచ్చు, సర్వర్ ఆల్సో వీ కెన్ యూజ్. సర్వర్ యూజ్ చేసిన దాన్ని అక్కడి నుంచి మూవ్ చేయలేము అంతే, ఎందుకంటే అన్నిటికీ కనెక్షన్ అయి ఉంటుంది కాబట్టి. ఇది ఓల్డెన్ డేస్ 90s 1990s different types of computers. Okay, next one, supercomputer. This is workstation designed for the high-end tasks or the lengthy programs. The next one is supercomputer. Name itself, definition. Supercomputer. Super ante high speed. A computer that was fastest in the world. సూపర్ కంప్యూటర్ కంటే ఇప్పుడు మన ల్యాప్టాప్లో సూపర్ ఉన్నాయి. అప్పుడు ఆ టైంలో ద ఫాస్టెస్ట్ డివైస్ ఈస్ ద సూపర్ కంప్యూటర్స్. ఓకే, సో నెక్స్ట్ వన్, అండ్ ఇట్ కెన్ బి యూజ్డ్ టు breaking codes and modeling weather systems, and it can be used in the aircraft designs. Next, mainframe. Where we are using this mainframe? Financial purpose. In bank sectors, we are using mainframes. See this? The large expensive computer capable of simultaneously processing data for hundreds of thousands of users. ఎక్కడ యూజ్ చేస్తున్నాం? ఫైనాన్షియల్లో. ఫర్ ఎగ్జాంపుల్, యూ కెన్ యూజ్ ATM. How many members are using the ATM? For example, SBI ATM. Okay, one area is having the one ATM. Like that, how many people are accessing that the same bank? In a second, lakhs of people are using the same financial transactions. That is a withdrawing amount or depositing amount. Avanni cheyalante, that should be high-end computer. So that is the mainframe. In the financial sectors or in the bank sectors, that can be used. SBI ఎంతమంది వాడతారమ్మా పర్ సెకండ్? Many lakhs of members in the India. All are at a time. But all ATMs are connected to only one server, SBI server. That is mainframe computers. So this can be used in business applications. Example is the ATM. Next one, PDA. Personal digital assistant. This one also no one is using right now. All are using mobile phones. Mobile place lo in the olden days, the PDS are present. Appudu evaru use chesalu PDS? High-end persons. Ante busy, వాళ్ళు ఎక్కువ మంది కమ్యూనికేట్ కావాలన్నా, ఫర్ ఎగ్జాంపుల్ మినిస్టర్స్, CM, PM, the high qualified people are using the PDS. Nowadays, all are using PDS. That is the mobile phones. Okay, so these are the different types of computers. Different types of computers. What are the different types of computers? First one is personal computer, then desktop, laptop, server, workstation, supercomputer, mainframes. And the last one is man-held or handled device, man-handled device, that is a PDA, the personal digital computers. Now, what are the hardware components in the computers? In all computers, you can take the any one, the personal, desktop, laptop, mainframe, workstation, server. These all computers are having the common hardware devices. Specifications different గా ఉండొచ్చు, but the all are having the common hardware products. What are the hardware components? Central processing unit. It can perform the applications and provide the data. Okay, there is a CPU, central processing unit, and input device. If you want to provide the data input, or if you want to type the program, so the input device is required, that is a keyboard and a mouse. Then if you want to observe the output, then we require the output device. If you want to store the data, or whatever process data, if you want to store for the future purpose, then you can use the memories. So these all are our hardware components. There is a cabinet, and it is having power supply unit also. SMPS, విన్నరా పేరు IT workshop లో? SMPS, switched mode power supply. Okay, so that switched mode power supply, and CPU device, there is a central processing unit, and then input devices, that is a keyboard and mouse to provide the data to the computer. Then input device are keyboard and mouse. Then sound card, istanu PPT. Then modem, kottadi. What is the use of modem? Modem, actually modem stands for modulator and demodulator. Modulator and demodulator. What is the use of modem? A device that sends and receives the data to and from computers over telephone lines. How many people are having the desktop computer in your homes? No one. All are laptops. Okay. For the laptop also, you are connecting the LAN wire, Ethernet cable. Connect చేస్తుండ్రు కదా? So that Ethernet cable is connected to the modem internally. A modem untene the computer can read the data from that cable. LAN wire, there is a local area network wire. So that is modulator and demodulator. Without this modem, we can't use the internet in our laptops or desktop computers. Nowadays, all are coming inbuilt. మన లోపలనే బిల్డ్ అయ్యి వచ్చేస్తున్నాయి. All are assembled in the single unit. Next, output device is a monitor. The output device can be see the outputs to watch the films or to watch the output of the any application software program. Next, the storage device. Storage devices. What are the different types of storage devices? ఇవన్నీ విన్నవే మీకు ఈ వర్డ్స్ అన్ని, బట్ క్వశ్చన్ కూడా వచ్చే ఛాన్స్ ఉంది. రైట్ ద different types of computers. So each computer name and explain what is the what purpose we are using that computers. Okay. Then what are the hardware components? You know already in real life also. So you can explain that. Next, storage device. Next hardware device is the storage. మీ ఫోన్లో 2 మెమరీస్ ఉన్నాయి కదమ్మా. What is the purpose of the 2 memories? ఫోన్ మీరే కొంటారా అంటే మీరే దాని అప్లికేషన్స్ ఏమున్నాయి సెర్చ్ చేసుకుంటారా, లేకుంటే మీ పేరెంట్స్ ఏది కొనిస్తే అది తీసుకుంటారా? మీరు సెర్చ్ చేస్తారు కదా. సో బిఫోర్ పర్చేసింగ్ ఏ మొబైల్ ఫోన్, వాట్ ఆర్ ద ఫీచర్స్ యు ఆర్ సీయింగ్? And ROM, the processor we'll see. We'll processor later. RAM and ROM. What is the purpose of RAM and what is the purpose of ROM? Both are memory devices. So what is the RAM and what is the ROM? What is the purpose of RAM and what is the purpose of ROM? RAM stands for random access memory. ROM stands for read-only memory. Random access memory is the temporary memory. Read-only memory is permanent memory. That is the storage device. Read-only memory is the storage device. The RAM is, ఇక్కడ ఏమవుతుందంటే, if you are in the one program, that program can be stored in the read-only memory. ఎప్పుడైతే మీరు సేవ్ అనే బటన్ ప్రెస్ చేస్తున్నారో, that memory can be stored in the computer memory. That is the read-only memory. Now, after saving that program, then you are executing. మీ ప్రాంప్ట్ వచ్చి ఎగ్జిక్యూషన్ ప్రాంప్ట్ వచ్చి you are executing that program. So whenever you are typing the executing the program, then that read-only memory can be fetching that code from read-only memory to random access memory. A random access memory lo that can be executing. Okay, there is a difference. So RAM size ఎక్కువ ఉంటే you can open the number of applications. మీరు కావాలంటే మీ ఇంట్లో పాత ఫోన్ ఉంటుంది, 2 GB RAM ఉంటుంది. Now you are using the 8 GB or 16 GB RAM. ఆ 2 GB RAM ఫోన్లో ఒక సినిమా ప్లే చేయండి, ఒక వీడియో ప్లే చేయండి, దాన్ని బ్యాక్గ్రౌండ్లో పెట్టి ఇంకో అప్లికేషన్ ఓపెన్ చేయండి, రాదు. Why? That is 2 GB. The entire 2 GB can be spent for the video only. ఆ 2 GBలో ఇంకా మెమరీ ఫ్రీ స్పేస్ లేదు ఇంకో అప్లికేషన్ రన్ చేయడానికి. సో దట్ ఈస్ ద ర్యాండమ్ యాక్సెస్ అండ్ రీడ్ ఓన్లీ మెమరీ. రీడ్ ఓన్లీ ఈస్ ద పర్మనెంట్, ర్యాండమ్ యాక్సెస్ మెమరీ ఈస్ టెంపరరీ మెమరీ. ఓకే, సో దిస్ పర్మనెంట్ మెమరీస్ ఆర్ డిఫరెంట్ టైప్స్: హార్డ్ డిస్క్స్, ఫ్లాపీ డిస్క్ అండ్ సిడి. ఈ రెండు నో వన్ ఈజ్ యూజింగ్ నౌ. ఫ్లాపీ ఐ థింక్ యూ చూడలేదు అనుకుంటా మీరు ఎవరు. చూసారా ఫ్లాపీ? ఫ్లాపీ ఈజ్ ద 4 MB సైజ్. యూ డోంట్ నో అబౌట్ ద ఫ్లాపీ. ఈ సిడి కంటే ముందు వచ్చింది ఇది ఫ్లాపీ. అది ఇన్సర్ట్ చేయడానికి దెర్ ఇస్ నో స్పేస్ ఇన్ యువర్ ల్యాప్టాప్స్ ఆర్ ఇన్ ద డెస్క్టాప్ కంప్యూటర్స్ ఆల్సో. మీరు ఓల్డ్ కంప్యూటర్ తీసుకుంటే దానికి ఒక ఫ్లాపీ డిస్క్ పెట్టడానికి ఉంటుంది. ఫ్లాపీ ఈజ్ ద సేమ్ సిమిలర్ టు ద సిడి. Okay, so there is a small memory device. There is a CD and DVD. Next to printer. You know the printer purpose. Next to sound speakers. Okay, next. What are the different hardware components? CPU, central processing unit, that can be placed in the CPU cabinet. Then input device, keyboard, mouse. Output device, monitor, any monitor. This is also monitor. Our screen also one of the monitor. Next, storage devices, read-only memory and random access memory. Then speakers, printers. These all are the external hardware devices are connected to the computer. Next one, the functional units in the computer. So after these discussions, what are the functional units in the computer? ఇప్పుడు డిస్కస్ చేసాం కొన్ని పాయింట్స్ కదా. నౌ వాట్ ఆర్ ద ఫంక్షనల్ యూనిట్స్ ఇన్ ద కంప్యూటర్? ఇంతకుముందు ఏవైతే చదివాం హార్డ్వేర్ కాంపోనెంట్స్ అన్ని ఆల్ ఆర్ ఫంక్షనల్ యూనిట్స్ ఇన్ ద కంప్యూటర్. దట్ ఈస్ ద ఇన్పుట్ డివైస్, అవుట్పుట్ డివైస్, ఇన్పుట్ and output devices. Input device can be used to enter the program or to provide the inputs to the computer. Okay, that is the input device. Next, output device. To display the outputs, we require the output device. Simply, that is the monitors. Display units, monitor. Okay, so that is a monitor. Then this is called the IO device. That is the input and output device. The next one is memory. That memory is the different types of memories, read-only memory and random access memory. So in that also different types are there. మీరు ఇంతవరకు నేను ఫ్లాపీ అన్న వాట్ ఈస్ ద హార్డ్ డిస్క్, ఫ్లాపీ అండ్ సిడి, ఇవి కాకుండా ఇంకా ఎనీ అదర్ మెమొరీ హెచ్డిడి అన్నారు కదా, దట్ ఈస్ కాల్ ద హార్డ్ డిస్క్ డ్రైవ్, అంటే హార్డ్ డిస్క్. దాని తర్వాత ఏమొచ్చింది, ఇన్ అవర్ ల్యాప్టాప్స్ అండ్ డెస్క్టాప్స్, ద ఓల్డ్ ల్యాప్టాప్స్ అండ్ డెస్క్టాప్స్ వీఆర్ యూజింగ్ హెచ్డిడి మెమొరీ, దట్ హార్డ్ డిస్క్ డ్రైవ్ మెమొరీస్. నవేడేస్ what is the latest memory? HDD. తర్వాత what is the next version of the memory? అవి డిఫరెంట్ టైప్స్, దాంట్లోనే వస్తాయి ఇవి కూడా. what is the after HDD, what is the next version of memory? SDD, solid disk drive. SDD. SDD కంటే అడ్వాన్స్డ్ మెమొరీ డివైస్ is SDD. Nowadays all the new computers and new laptops are designed with SDDs only. Okay, so that is a memory device. Then ALU, the arithmetic logic unit. What is the purpose of arithmetic logic unit? It can perform the arithmetic operations and the logical operations that will provide the output to the users. Okay, so that is ALU, arithmetic logic unit, and control unit. The control unit can be controlling the processor. That is, control unit means that is the reading the data or writing the data. What is the meaning of reading and writing data in the computer? What is the difference between the printf and scanf? In C language. In C language, what is the scanf and what is the printf? Scanf, first printf, okay, scanf చెప్పండి. Reading the data from the memory device. If you are writing the scanf and in specify the operand, then the computer can be reading the data from that memory device, particular that variable, that is a scanf. Printf, that can be writing to the program memory, and the same can be displaying on the computer also. Okay, so that is a scanf is a input or output. Scanf is a input and printf is output. And similarly here, that is controlled by the processor. That is the control unit. Okay, next one. So this arithmetic logic unit, that is the ALU and control unit together is called central processing unit, CPU. The control unit and arithmetic logic unit, the together is called the processor, that is the central processor. Okay, so these are the different functional units in our computers. All different types of computers, the basic different parts are the input and the output. This is called the IO device, and the processor, that is the ALU, arithmetic logic unit, and the control unit together is called processor. And this processor is required the memory unit. Okay, so these are the different functional units. The information handled by a computer. Okay, so instructions and machine instructions. The instruction or machine instructions means that is a computer understandable language. Computer understandable language that can be stored in the memory. And then the govern the transfer of information within a computer as well as between the computers and its IO devices. The computer can transfer the data within the device. Within the device. That is the read-only memory to random access memory. While executing the program, the data can be fetching from the read-only memory to random access memory. There is a data transfer from the read-only memory to random access memory. And from that memory device to the output device. Okay, there is a data transfer. And data can be transferred from the one device to other device. Similarly, the server to remaining all other computers. That is the data transfer. Then specify the arithmetic operations. So which operation we are specifying, that is addition or subtraction or division, the ALU can perform, or the logical operations. That is logical. What are the logical operations? AND operation, OR operation, NOT operation, XOR operation, NAND operation, NOR operation, and XNOR operation. These are the logical. And other one is the shifting. Left shift, right shift, and rotate instructions. Okay. So now then the program and data both are different. C is equal to A plus B is the program, and C, A, B are the data. The C is the output data, A, B are input data. Next, and used operands by the instructions. That is the data can be used as a operands. The source program means the which program we are writing, that is called the source program. Then the encoding the binary data. That can be converting the decimal to binary while processing the data. After processing the data, that binary data can be converted to decimal data. Okay, so there is this all can be done by the computer. Next, memories. Different types of memories. Primary memory and secondary memory. Can you differentiate what is primary and what is secondary? See the diagram and tell me at least. What is the difference between the primary memory and the secondary memory? Primary memory and secondary memory. Both are different. Both are memory devices. The primary and secondary both are memory elements only. But what is the difference? What is called the primary and why that is called the secondary memory? What is the difference? Someone said primary memory and secondary memory. Primary means primary memory. ఇవన్నీ జనరల్ మీకు ఒకసారి కంప్యూటర్ ఒక్కసారి మీరు థింక్ చేస్తే ఆటోమేటిక్లీ యూ విల్ గెట్ ద ఆన్సర్స్. ప్రైమరీ మెమొరీ, secondary memory. The primary memory means internal memory. You are using your mobile phone. Your mobile phone internal memory is the 4 GB RAM and 64 GB read-only memory. That is the internal memory. If you are not much the data, that memory, then you are inserting one external memory. That is SD. What is that? SD cards. Storage cards. That is ఏమంటారు దాన్ని? చిన్నవి. memory cards. Memory card. A memory card insert చేస్తున్నా, that is secondary memory. So the primary memories are internal memory. That internal memories are the random access memory and the read-only memory. Random access and read-only memory. Then the random access memory is based on the designing of that structure of that RAM device that can be divided into SRAM and DRAM. SRAM means the static random access memory and DRAM stands for the dynamic random access memory. DRAM stands for dynamic random access memory. Okay, the structure is different. The static RAM is a slow device and dynamic RAM is faster device. Nowadays, we are using in our mobile phones, the RAM is the DD-RAM. DD-RAM. And then the read-only memories are non-volatile. Idi RAM. What is the meaning of non-volatile? You have to remember the word volatile and non-volatile memories. Non-volatile means if the power is switched off, the data can be remain stored without lose the data while power is switched off. For example, మీరు ఒక మూవీ చూస్తున్నారు ల్యాప్టాప్లో, సడన్గా షట్ డౌన్ అయిపోయింది, మొత్తం బ్యాటరీ అయిపోయి షట్ డౌన్ అయింది. ఆ సినిమా ప్లే అవుతున్నది, ఆ సినిమా డిలీట్ అవుతుందా మన మెమొరీలోకి వెళ్ళి, ల్యాప్టాప్ మెమొరీలోకి వెళ్ళి? నో. బట్ దట్ ఈస్ ద నాన్ వాలటైల్ మెమొరీ. ద సేమ్ ర్యామ్ ఈస్ ద వాలటైల్ మెమొరీ. మీరు సినిమాని ఒక వాచ్ చూస్తున్నారు, రైట్? ద సేమ్ పవర్ పోయింది, పవర్ ఆన్ చేశారు, ద సేమ్ మూవీ కెన్ బి ప్లేయింగ్? No. Again, you need to go to that video location, then play the button. So that means the RAM is the volatile memory. That is the temporary memory. Whenever the power is switched off, the content of the RAM will be lost. అందులో ఉంటుంది, ఎక్కడ? మెయిన్ లొకేషన్లో ఉంటుంది, బట్ ద ప్లేయింగ్ కెన్ బి నాట్ డన్. ఓకే, దట్ ఈస్ ద read-only memory. And these read-only memories are different types. One is PROM. PROM stands for the programmable read-only memory. The programmable, ఇవన్నీ మళ్ళీ మీకు ఎప్పుడు వస్తాయమ్మా? 4th యూనిట్లో వస్తాయి, మెమరీ సిస్టమ్ డిజైన్లో ఉన్నాయి ఇవన్నీ. You will get in that. Okay, so PROM and PROM stands for the programmable read-only memory. Programmable read-only memory అంటే, for example, this is the PROM. Purpose to store the data. ఒకసారి మనం డేటా ఇన్సర్ట్ చేశాం, ఇందులో ఇన్సర్ట్ చేసిన తర్వాత then the programmer or user cannot reuse this device. If you want to delete this device, then you can reach the who manufactured this device. వాళ్ళ దగ్గరికి తీసుకెళ్ళి then erase చేసుకొని రావాలి. That is the PROM, the programmable read-only memory. That is the PROM. And next one is EPROM, electrically erasable read-only programmable memory. Electrically erasable. So by applying the electrical voids or electrical supply, the data can be erased. That is the EPROM. Then next one is E2 PROM. That is the electrically erasable programmable read-only memory. This is not electrical. This is the EPROM. EPROM is the erasable programmable read-only memory. This erasable programmable read-only memory can be erased by applying the ultraviolet rays, UV rays. By applying the UV rays to this memory device, the data can be lost and then you can use the reuse again. Okay, that is the electrical erasable. Ivi evi manam we are not using. PROM vadatledu, EPROM vadatledu, even E2 PROM also we are not using. The E2 PROM, ikkada PROM lo enti By applying the UV rays, the data can be erased in the memory device. And in the E square PRAM, there is a electrically erasable programmable read-only memory. By applying the electrical supply, the data can be removed. Not direct here. So there is a suitable voltage range. So applying the suitable voltage values, the data can be erased this electrically read-only programmable memory. After that, the one more memory is the flash memory. Flash memory ante, for example, you can assume SD cards. Simple mana erase అని కొట్టంగానే data మొత్తం erase అయిపోతుంది. So that is the flash memory. So these all are the primary memories. ఇప్పుడు మన అన్ని SGD and SSD all are flash memories only. Okay. Now coming to the secondary memories. The secondary memory means we are using the external memory element. We are using external memory. Similarly, our for mobile phones, input 64 GB, 120 GB mobiles వస్తున్నాయి. అంతకుముందు ఎంత GB? 8 GB మెమొరీ ఉండేది. లేదంటే 16 GB రీడ్ ఓన్లీ మెమొరీ. అప్పుడు మనకు మెమొరీ సరిపోదు. 2 సినిమాలు దాంట్లో పెట్టంగానే మెమొరీ మొత్తం అయిపోయింది. అప్పుడు ఏంటి? వీఆర్ ఇన్సర్టింగ్ ద మెమొరీ కార్డ్స్, SD cards. So that all external memory devices are called external memories. That is the SDD, hard disk drive, and SSD, solid state disks, and compact disk, floppy disk, and magnetic tape. Magnetic tape విన్నారా? Magnetic tape. ఎక్కడ చూశారు magnetic tape ని? Magnetic tape. కొన్ని సినిమా రిలేటెడ్ సినిమాలు తీస్తుంటారు. అంటే ఒక డైరెక్టర్గా ఎలా ఎదిగాడు అలా బయోగ్రఫీకి చేస్తుంటారు కదా. అందులో మీకు డైరెక్ట్ ఏది సినిమా తీసి మళ్ళీ దాన్ని సరిగా రాకుంటే మళ్ళీ క్యాప్చర్ చేస్తారు. అంటే రీల్స్ అన్ని కట్ చేస్తుంటారు ఇట్లా. దట్ ఈస్ ద మ్యాగ్నెటిక్ టేప్. ఓకే. లేకుంటే ఓల్డ్ టేప్ రికార్డ్స్ లో క్యాసెట్ ఉంటుంది, చూసారా క్యాసెట్? సో ఇన్ దట్ సమ్ మ్యాగ్నెటిక్ వైర్ ఉంటుంది, ఒక 2 centimeters విడ్త్ ఉండి లాంగ్ ఉంటుంది. దట్ ఈస్ ద మ్యాగ్నెటిక్ టేప్. సో దీస్ ఆర్ ద మెమొరీ ఎలిమెంట్స్. The memory can be used in the different purposes. Storing the program or code. There is a program memory is called that code memory and data memory. And the two different memories are present. There is a primary memory and external memory, secondary memory. There is a external memory to the processor. Next one is arithmetic and logic unit. This is one of the functional unit of computer. This can perform the all logical operations: arithmetic operation, addition, subtraction, multiplication, division. Multiplication, addition, subtraction, multiplication, division అవి ఊరికే ప్రోగ్రామ్ రాస్తే వచ్చేటి కాదమ్మా. ఫస్ట్ we need to design the hardware structure, hardware algorithm to perform the addition operation. I think you studied in the 3rd unit, computer arithmetic. You design the algorithm, hardware అంట. ఆ హార్డ్వేర్ లేకుండా we can't run the program. Okay, that can perform all arithmetic operations. That is addition, subtraction, multiplication, division, and the logical operations and or not, NAND, XOR, XNOR logical operations, and some shifting operations. That is shift left, shift right, rotate left, rotate right. Then to perform this all arithmetic and logical operations, we require the registers. Computer registers. Okay, then control of arithmetic logic here, that is the writing or reading. So this all comes under ALU control unit. This can be controlling the computer. Okay. Okay. Now you can assume the simple program. That program is having the 5 instructions. That is whatever it is. 5 instructions. Instruction 1, instruction 2, 3, 4, 5. The instruction 1 located in the memory device, there is a 001 location. Right? The 001 location. So in that simple instructions, what is the first instruction can be executed? I1. After that, I2. Then I3, then I4, and then I5. How the computer knows the I2 is the second instruction? How the computer knows the I2 is the second instruction? Here. PC stands for PC stands for processor. PC endemma. Processing control. Any other answers? Okay. The PC stands for the program counter. PC stands for program counter. The purpose of the program counter is it is holding the address of next instruction. Address of next instruction. So first the I1 is executing. While executing this I1 instruction, the processor is loading with this address. The processor is loading with the second instruction address. So the which address which instruction is available in this address that can be execute next. Sometimes this program can be jumping to this I21. I21. ఫంక్షన్ ప్రోగ్రామ్స్ గుర్తున్నాయా? ఫంక్షన్స్. ఒక ప్రోగ్రామ్ రాస్తారు, కొన్ని 4 లైన్లు రాసిన తర్వాత యు ఆర్ యూజింగ్ ద ఫంక్షన్ ఇన్ సి లాంగ్వేజ్. యూజ్ చేస్తుండ్రా? డిస్ప్లే ఫంక్షన్ ఆర్ వాట్ ఇస్ టెల్ మీ సమ్ arithmetic ఫంక్షన్ అంటే ఫంక్షన్స్. వాట్ ఇస్ ద పర్పస్ ఆఫ్ ఫంక్షన్? ద సేమ్ టాస్క్ కెన్ బి యూజింగ్ ద మల్టిపుల్ టైమ్స్. ఆ మల్టిపుల్ టైమ్స్ రాయాలంటే అంటే ఆ పర్పస్ ఎక్కడైతే వస్తుందో, ఫర్ ఎగ్జాంపుల్ అడిషన్ అని ఎక్కడైతే వస్తుందో ప్రతిసారి వీ నీడ్ టు రైట్ దట్ సెట్ ఆఫ్ లైన్స్. That set of lines are repeating by number of times. Because of that, the program length will increase to avoid the increase in the number of lines in the program, we are using the functions, right? So to avoid that, we are using the functions. So that functions, we are defining it only once in the program, not in the multiple times. We are calling them multiple times. So now here, if you are executing the I2 instruction, the controller is saying that you can jump to I21. In that case, the PC can be storing this instruction address. The PC can be loading internally with this address. Then that is executing the program. After completing this, again it is shifting to I3 instruction. That is the purpose of the program counter. The program counter is holding the address of next instruction. Okay, so now here PC can be holding the next instruction address. That address can be reading. So in that address location, the which instruction is present. So in that instruction, what are the variables are present? That variables data can be loaded to the registers. There is a register 1 and register 2. Now the ALU can be performed, for example, the two register 1 and register 2. This ALU, for example, addition program, this ALU can be adding the register 1 content and register 2 content. Then output we are placing in the, again, data memory. So that is the flow in the computers. If you are writing the initially I taken C is equal to A plus B, this can be stored in the 0100. That instruction is available in the 0100 memory here. So our memory changes in the processor. This program counter is loaded with 0100. So in that location, this code is present. That is the C is equal to A plus B, equivalent to opcode, machine code. Machine understandable code is present in that 0100 location. So here, this content is the 0100. Now this in address data can be loading here. That is the C is equal to A plus B, not C here. You can remove C. A and B. Now this A and B, here you can take the A register and here the B register. So in register 1, we are placing the A content, and in the B register 2, we are placing the B content, and here this can be performing A plus B. Now that can be stored here. C is equal to here. The added data can be placed in the variable C. So that is the flow of simple A is equal to B instruction. C is equal to A plus B. Ela flow avutundi? Idi location. Ee location we are reading the operands. And what is the operation we are going to perform? Then that can be informed to ALU. Then here the register bank. So this different data. Meer processor lo, if you want to perform the any task, that can be that task lo what are the variables are present, that all variables data are loaded into the registers. That is A and B, then here the ALU can be adding, then assigning the variable C. This operation for all the instructions. Instruction 1, same operation. Instruction 2, same operation. That is, here I am taking the example is the A plus B. But any operation can be flow. So the each and every instruction is flowing. The flow is like this. Okay. Again, same. I1, I2, I3, I4, I5. First, this one is executing, right? While executing this program, this instruction address is loaded into PC, program counter. Okay. E program, this is called first time చేయాలమ్మా fetch చేయాలి అంటే అడ్రస్ ఫైండ్ అవుట్ చేయాలి. So that is called instruction fetch. After finding the location, fetch data. Fetch means reading the data from the memory. That is the fetch cycle. Next, after fetching, fetch చేసిన తర్వాత ఏం చేయాలి? C is equal to A plus B అని ఉంది. అది అలానే సేవ్ అవుతుందా? యాజ్ ఇట్ ఈస్ సేవ్ అవుతుందా మెమొరీలో? దానికి షూటబుల్ మిషన్ కోడ్ ఉంటుంది. ఆ మిషన్ కోడ్ రీడ్ చేస్తుంది. ఆఫ్టర్ రీడింగ్ దట్ మిషన్ కోడ్ వీ నీడ్ టు డికోడ్. డికోడ్ చేయలేదని. డికోడ్ అంటే ఏంది? C is equal to A plus B అని రాశాం అంటే arithmetic ఆపరేషన్ ఉంది. So we need to find out the which arithmetic operation is present and what are the data values are present. That is the decoding operation. First fetch చేయాలి, తర్వాత decode అంటే ఆపరేషన్ ని ఆపరెంట్స్ ని సెపరేట్ చేయాలి. ఓకే, దట్ ఈస్ కాల్డ్ decode. Right? So decode ఇది decode, then after decoding execute అంటే A plus B addition perform చేయండి. Here instruction is C is equal to A plus B అనే instruction ఉంది. So here you can separate add operation and AB. AB are operands and plus is the addition operator. So the processor is instructing we are going to perform addition and variables are AB. So that is the decoding operation. Now here perform the A plus B. Execute the instruction. After executing instruction, then assign this value to C is equal to A plus B. ఇక్కడ యాడ్ చేస్తున్నామా? That value can be assigning to the C. Next, after loading into the memory, if you want to display and you can read from the memory. Okay, so these are 5 steps for the each and every line. మీకు I1 ఉంటే 5 steps are required. That is the fetching the data, decoding, executing, writing, fetching, decoding, executing, reading the data to the, and then writing. And for the display writing and display purpose, you can read the data from the memory device. So these are the 5 steps. ఇక్కడ ఎన్ని? ఓకే, ఈ 5 steps ఒకేసారి ఎగ్జిక్యూట్ అవుతాయా? 1 by 1. ఫర్ ఎగ్జాంపుల్, మీరు ఏమన్నా పైప్ లైన్ అనే కాన్సెప్ట్ ఎక్కడన్నా విన్నారా? పైప్ లైన్. ఓకే, హియర్ 5 ఇన్స్ట్రక్షన్స్ ఉన్నాయి. ఒక్కొక్క ఇన్స్ట్రక్షన్ కి 2 seconds టైం అండి. ఫర్ ఎగ్జాంపుల్, ఒక ఇన్స్ట్రక్షన్ కి 5 steps ఏంటి? ఫెచ్, డికోడ్, ఎగ్జిక్యూట్, రైట్, రీడ్. ఎన్ని? ఒక ఇన్స్ట్రక్షన్ మొత్తం ఎన్ని అవుతాయి? ఎన్ని? వాట్ ఈస్ ద టైం? 10 seconds. ఫెచ్చింగ్ కి 2 seconds, decode 2 seconds, executing 2 seconds, writing 2 seconds, again reading 2 seconds. How much time total? 10 seconds. What is the first instruction? 10 seconds. Next 20, 30, 40, 50. 5 instructions ఉంటే 50 seconds కావాలా? 5 instructions కే 50 seconds ఉంటే 100 lines ఉంటే 100 into 2 seconds ఎంత టైం పడుతుంది? ఎంత? 100 lines ఉంటాయి. ఒక్కొక్క సెకండ్కి 100 lines ఉంటాయి. 100 into 10 seconds ఎంత? 1000 seconds. 1000 seconds అని ఎంత టైము? 1000 by 60 ఎన్ని మినిట్స్ వస్తుంది? 900 అంటే 1 hour 30 minutes. 1 hour 30 minutes time 100 instructions execute కావాలంటే. So to avoid that we are using pipelining concept. Pipelining అంటే ఏంటంటే how many different steps are there? 5 different steps. ఒక ఇన్స్ట్రక్షన్ ఫెచ్ చేసినప్పుడు ఫెచ్ అవుతుంది. నెక్స్ట్ ఆ ఫెచ్ అయిన తర్వాత నెక్స్ట్ ఏ స్టేజ్కి వెళ్తుంది? అది సెకండ్ ఇన్స్ట్రక్షన్ డికోడింగ్. డికోడింగ్కి వెళ్ళినప్పుడు ఫెచ్ ఫ్రీగా ఉందా, బిజీ ఉందా? ఫెచ్ లేకుంటే ఫెచ్, ఎగ్జిక్యూట్, డికోడ్, సారీ, ఫెచ్, డికోడ్, ఎగ్జిక్యూట్, మెమొరీ రైట్, మెమొరీ రీడ్. ఓకే, ఇక్కడ I1 రీడ్ అయింది. రీడ్ తర్వాత ఎక్కడికి వెళ్తుంది? హియర్ I1. ఇక్కడ I1 ఉన్నప్పుడు ఇక్కడ ఏమవుతుందమ్మా? I2 కెన్ బి ఫెచ్. ఫ్రీగా ఉంది కదా I1. దెన్ ఇది నెక్స్ట్ ఇక్కడికి వెళ్తుంది. ఇక్కడికి వెళ్ళినప్పుడు ఇక్కడ ఏమొస్తుంది? ఇక్కడ I2 వస్తుంది, ఇక్కడ I3 ఫెచ్ అవుతుంది. సో దట్ కాన్సెప్ట్ ఈజ్ కాల్డ్ పైప్లైనింగ్ కాన్సెప్ట్. I think you are not having in your syllabus, but you can remember that word, pipelining. The parallelly executing the multiple instructions without overlapping. The pipelining is executing multiple instructions without overlapping. Basic operational concepts. Lunch time ఎప్పుడు? Okay. See. Okay. What is the activity in a computer is governed by the instructions. Activity governed by the activity in a computer is governed by the instructions. And any activity can be simply C program. Any program this we are writing the instructions. Okay. Now perform the task. An appropriate program consisting of list of instructions is stored in the memory. Simple C is equal to A plus B. Ante single word రాసేస్తారా? C is equal to A plus B అంటే C language లో program that will give the output ఇస్తుందా? లేదు. ఫస్ట్ ఏంటి? మెయిన్ హెడర్ ఫైల్ ఇవ్వాలి ఫస్ట్. దెన్ మెయిన్ స్టార్ట్ చేసి నెక్స్ట్ అసైన్ ద వేరియబుల్స్, దట్ ఈస్ ఇంటీజర్ టైప్ ఆర్ లాంగ్ ఆర్ ఫ్లోట్ ఆర్ డబుల్. int a comma b comma c, right? That is the variable assignment. After assigning the data type of the variable, then a is equal, assign the a value and b values. Third step. Fourth line, write c is equal to a plus b. Then store, that is the printf percentile d. Right, that means you can write that store the output values in the program. So that is the set of instructions. The perform a task, an appropriate program consisting of list of instructions is stored in the memory. The next one, the individual instructions are brought from the memory into the processor which executes the specified operations. మీకు ఇంతకుముందు 5 instructions తీసుకున్నాం. First, the first instruction can be fetching from the memory. After that, I2 can be fetching, then decode and execute, then I3. So the same steps we are following here, and data to be used as a operands and also stored in the memory. After performing the A plus B addition operation, then you can store the data into the memory device. Okay, so that is a basic. Now, the simple diagram you can see here. Primary memory, that is the read-only and random access memories. The primary memory and processor. How The devices are connected. You can see here the processor and memory device. And two registers we are using. One is MAR and one is MDR. MAR stands for the memory address register. MDR stands for memory data register. The two registers are having two different arrows. Anybody can tell me what is why the memory is having the single direction and the MDR is having the two directions? Memory address register and the MDR memory data register. Memory address register means that can identifying the instruction memory. Instruction memory. You can see A అనే వేరియబుల్ 001 లొకేషన్ లో ఉంటే the processor is identified the memory location of variable A, that is here. A, after identifying the variable A, for this location, that is the 001 location. So in this location, the which data is available that can be placing in the memory data register. Now this data register is sending the data to the memory to processor. అంటే ఇక్కడ ఏమొచ్చింది ఇప్పుడు ప్రాసెసర్ ఏం చేస్తుందమ్మా? The processor is identifying the where that operand is located or loaded. ఏ లొకేషన్ లో ఉందో that can be identified by the processor. After identifying this data, that is the variable A, can be read by the processor through using MDR, memory data register. After reading this memory data register, then first A find out చేస్తుంది, then B also it will find. Okay, now the processor is performing A plus B. After performing the A plus B, the result C can be loaded into the memory device. So how many directions for the MDR? One is the reading the data, other one is writing the data, receiving, sending. So that's why the MDR is having the two directions, reading direction and writing direction. Okay, so that is the MDR. But you can see here the memory address register is identifying simply the where this variable is present. After identifying, the data can be carried by MDR. If there is no connection between the primary memory and the processor, we can't get the data. ఇది మనం పైన చూడం, ఎక్కడ మన ల్యాప్టాప్ లో కానీ డెస్క్టాప్ లో ఎక్కడ చూడం. This is the internal structure, how the memories and how the processors are connected with the help of this memory address register and memory data register. So here the address register and this one is the data register. Okay. Simple load the memory address into MAR. C, first A, B, C is equal to A plus B. This is the instruction 1, instruction 2 and instruction 3. A is equal to 2, B is equal to 3 and int A comma B comma C, this is the instruction 0. Right? The instruction 0 we are defining the variables, that is the data type, integer type ABC I1 we are assigning the 2, 3, and then we are adding. Now here, to read the data from the memory, first, the load the memory address into MER. Ante here, this I0 instruction is where it is loaded or located in the code memory. That can be loaded. That address is loaded to the MER. After loading into the MER, issue the control signal. In control signal, here one control signal is there. Issue the control signal. So this control signal will give read or the read operation or write operation. Read operation ante this direction. Write operation is this. Okay. So the control, the processor is giving the issuing the control signal. Reading operation or writing operation. Okay. So then load the memory, then read the operation, then perform the, after reading, the data can be loaded into MDR. That is the reading memory read, then writing, load the memory address. Right, read చేయాలంటే ఏం కావాలి? Location లో ఎక్కడ we need to write. We need to identify. After identifying that, then you can write the data to the MDR. Load the data into the MDR. Then the processor is issuing the write signal. Write signal and read signal. This is a reading operation. Reading ఏం చేయాలి? First identify the memory location. ఎక్కడ ఉంది? After identifying, then that processor is issuing the read signal. Our read వచ్చిన తర్వాత the data can be placed in the MDR. For the write signal ఏంటి? What is the flow for the write? Right? Here also first identify the memory location. After identify the memory location, then what is the next step? ఈ బాటిల్ తీసుకున్నా. I read the data. I have the ఎక్కడ ఫస్ట్ ఏం కావాలి? First pick the data. Data pick చేసిన తర్వాత you can identify where we need to place. Identify this location. After identifying the location, then this data can be loaded into the data memory. That is the MDR and MDR to that. Okay. So that is load the memory address first, then load the data into that MDR register. Then after MDR, issue the control signal to the write operation. Okay. So this is writing operation. Next, registers. Just 2 minutes. Different types of registers. Instruction register, program counter, general purpose, memory address, and memory data. Memory address register and memory data register. Instruction register ante oka instruction undi. Don't get confused from this two registers. అదేంటి పైన ఏంటి? ఇన్స్ట్రక్షన్ రిజిస్టర్. ఇది మెమొరీ అడ్రస్ రిజిస్టర్. మెమొరీ అడ్రస్ రిజిస్టర్ కెన్ ఐడెంటిఫై ద ప్రోగ్రామ్ కోడ్ ఆర్ డేటా. ఆ ఇన్స్ట్రక్షన్ ఏ లొకేషన్ లో ఉందో దట్ కెన్ ఐడెంటిఫై. ఆఫ్టర్ ఐడెంటిఫై ఆ లొకేషన్ లో ద విచ్ ఇన్స్ట్రక్షన్ ఈస్ ప్రజెంట్, దట్ ఇన్స్ట్రక్షన్ కెన్ బి క్యారీడ్ బై ద ఇన్స్ట్రక్షన్ రిజిస్టర్. ఇన్స్ట్రక్షన్ రిజిస్టర్ ఏంటి? ఆ ఇన్స్ట్రక్షన్ ఆప్ కోడ్, మిషన్ కోడ్ ని క్యారీ చేస్తుంది. దట్ ఈస్ ఇన్స్ట్రక్షన్ రిజిస్టర్. మెమొరీ అడ్రస్ రిజిస్టర్ అంటే ఆ ఇన్స్ట్రక్షన్ ఏ లొకేషన్ లో ఉందో దట్ లొకేషన్ అడ్రస్ కెన్ బి క్యారీడ్ బై అడ్రస్ రిజిస్టర్. అండ్ కమింగ్ ద డేటా రిజిస్టర్. సో ఇన్ దట్ ప్రోగ్రామ్ what the variables are using, that data can be carried by data registers. Next, the general purpose registers, our values. That values can be placed in the general purpose registers. Then program counter, the which line can be order of execution of the instructions, that can be maintained by the program counter. That is, this can hold the address of next instruction. Okay. So these are the registers, and these registers sizes are depends on processors. The which processor you are designing. Based on that, we can give the sizes. But the basic sizes for the instruction register is 16-bit, and the program counter is a 16-bit. Then the general purpose register 8-bit or 16-bit, and memory address register is depending on the memory size. Okay, and memory data register depending on the integer or float or double. Okay, there is a different types of registers. Next, how we are using this memories and on how we are accessing, then we'll discuss after the lunch. Okay.